Hey there, kids. Welcome to 5.1b. Today, y'all, we're going to be looking at 5.1b. We're going to be looking at perpendicular bisectors and angle bisectors and all the other bisectors. Quick reminder, bisector means to cut into two. Cut into two what? Two equal parts. Bisect. Sect, cut, by, two. Bisect cuts into two equal parts. First one we're going to look at today is a perpendicular bisector. So if you're looking at a perpendicular bisector, like over here we have CD is perpendicular to AB, so it makes this right angle. So that means AD is congruent to BD because it's a perpendicular bisector, cuts in half. Think about this as a roof truss, right? Up in your rafters. If you were to put a log from the peak to the bottom of it, you'd make a right angle. And both sides of your roof would be the same measure, and both of these halves would be the same measure. Okay, so if this is a roof, we're going to want AC, the measure of AC, to be equal to the measure of BC. Okay, so if these two things are congruent, our roof has to be congruent too. You don't want a lopsided roof, that looks silly willy. Okay, another one of our good old theorems, theorfunds as I like to call them. Sorry, I apologize. Would be the converse. The converse says if you draw a perpendicular line to AB and AC and CB are congruent. So if your roof is congruent, then the bottom part of this truss has to be congruent as well, and CD has to be perpendicular. So if we know that these two things are congruent, we know CD has to be perpendicular to AB. That's a perpendicular sign, of course. And we would know that AD would be congruent, have the same measure as DB. Or BD. Or it doesn't matter when you're saying congruence. Okay? So let's see what this all actually means. So let's take a look at number one. On number one, this line is perpendicular to my base. My base is cut into two equal parts. If each of these parts are equal, then each of these parts are equal or congruent. So what do I do with these two equations? Well, I set them equal to each other. Alright, and using some fancy algebra, I get 72 equals 6x, or x equals 12. 12 equals x, same thing. Alright, not so bad. Let's take a look at, well, like number three. Number three, we got to find RS. So we're looking for the list length. Again, we have a perpendicular. These two things are congruent. If those are congruent, then my roof has to be congruent. So then I'm going to set these two equations equal to each other. And using my handy dandy algebra, I get 3x equals 27. Or x equals 9. Now I'm not done yet because I'm not looking for x on this one. I'm looking for RS. So what I'm going to do is I'm going to take that 9 and I'm going to plug it back into that equation. So I'm going to do 4 times 9 plus 5. And 4 times 9 is 36 plus 5 is 41. So RS, what we're looking for, is 41 hot dogs. They only give us a unit. I don't know. Alright. Check for time real quick. Alright. Whoa, letters are staying there. Alright, we got time. I'm going to go on to angle bisectors now. An angle bisector, well, that cuts an angle into two equal parts. That cuts an angle in half. Now, what's interesting about an angle bisector is, if you have an angle bisector, and you pick 2 points, and they're both the same distance. Distance is measured perpendicularly. then, or I'm sorry, you pick 2 points, and they're both perpendicular, and they cross the same point, then those lines are congruent. The definition of this, I don't care as much, but I hope when you look at this, you can kind of see a pattern emerge. So like you have AD is being bisected, so these two pieces are equal. AB, these are both perpendicular lines. If that is true, then BD has to be congruent to CD. These have to be the same length, because those are congruent triangles, okay? That's what we're trying to get at here. We have angle, angle, side, so that means all the pieces are going to be congruent. So if you don't know the angle bisector theorem, that's fine. But I want you to recognize that these are two congruent triangles, so all the pieces would be congruent. Okay, so there's multiple ways to do this. Will I ever make you memorize this theorem right here? No. Will I ever make you memorize this? No. Will I want you to be able to use them? Yeah, I do. It's good for your spatial reasoning in your brain, in your parietal lobe. You want that to be big. You don't want to be walking around like a numbskull without a good parietal lobe. That'd be silly. I digress. Now the converse is also true, which says if these things are congruent, then this is an angle bisector. Okay, so the opposite is also true. If these two pieces are congruent, then AD bisects angle BAC. Okay, again, you don't have to memorize that, but let's be able to use it. That's more important. So let's use it. All right, let's look at this. Number 8. We have an angle bisector. We have two right angles here, right? So right away, I need to ask myself, or look at the picture. If that's an angle bisector, and remember, the bigger the angle, the bigger the opposite side. So angles that are congruent usually produce sides that are equal. Or you could look at, like, I have angle, angle, side, because reflexive, so those pieces are congruent. Or you could use the angle bisector theorem. Either way, you're going to set your two sides equal to each other. And then you're going to solve using some handy dandy math. You get 5x equals 35, or x equals 7. Okay, quick check for time. All right, perfect. Time for one more. All right, now this one, let's find the angle on number 9. Let's find x. So here I have two congruent sides, and they're both perpendicular, and they share a side. So what do I know about these angles? That's right, they're congruent. So I'm going to set these equal to each other. And from my handy math, I get 30 equals 3x. And I get 10 equals x. Easy peasy, set them equal. I hope you guys are starting to realize that's a common theme in geometry. Have questions, please feel free to ask. I'll do some more in class. Have a great day.